Just a couple introductory things before I start. I appreciate you mentioning my dad, Marlon Downey. I did not go off on my own, though. He is my mentor and chairman of our company, and we work very, very close together. And I just want to make sure everybody's aware Roxanne is actually founded by Marlon, and I joined him about 10 years ago. Okay, so it's nice to be here at HGS. I've been fortunate to have been invited to give this talk several times. I was at Dallas sites last month, Tulsa Geological Society, and Oklahoma City Geological Society. And what's really great, though, is coming back here to Houston. It's my hometown. I'm honored to have several of my staff here at the table, who I need to credit with much of the work that I'm going to show you today. So, we're all sitting here today, and we're probably asking ourselves, why are we all sitting here talking about exploration during historically low oil prices? And my answer to that's pretty simple. I've been doing this for 35 years, strictly as an explorationist, frontier explorationist, new play explorationist. And I will say some of the best concepts have been generated during the worst of times, when we have time to really sit back and get back to fundamental basics and to think about what we're doing. And I'm going to say also that the companies, the people that are going to be the last man standing through this are going to be the people that got in, did their homework, and accessed the best parts, the best plays, and been able to weather the storm. And at the end of the day, they'll always be the winners. So I love exploration. I'm excited about it. Good times, bad times. What I'd like to share with you today over the next about 30 minutes is some of the work we've been doing in our shop to generate new exploration plays. And what I'll share with you is some of the thinking, some of the analytical approaches we've used to convince ourselves to take an early entry position and high grade the best parts of the play. And I'm going to be doing this by showing examples from 4 different plays. And in each of those plays, we'll be showing some of the thinking that went into each of these, but probably more importantly is you'll see over time how our play concepts have evolved with changes in commodity prices and changes in technology. Now, all the plays I'm going to show you today are in various stages of exploration and production. But I'm not here to show you production curves. I'm here to show you the very first maps, some of them back in 2008, hand-drawn, and some of the first thinking that led us to put our own money in these leases. Back and forth here. Okay, so let me give you a little bit of background on our company. Roxanne Oil Company was founded about 20 years ago by my father, Marlon Downey. And over the past decade, we focused exclusively on generating new early entry resource plays. We've been very fortunate that over the past 10 years, our consulting group, Roxanne Associates, has been under almost continuous exclusive consulting contracts for major oil companies, Shell, Marathon, and recently a very large New York exploration fund, where we've been assisting those staff in putting them into these new play concepts, early entry. And what's unique about our company, is that we put our money in where our mouth is. And every project we've ever recommended to clients, that we recommend to our partners, we co-invest. So what I'd like to do is show you a little bit, let me get my pointer here, is give you an idea of some of the generation in our concepts over the years. We currently hold about 600,000 acres in working and royalty interest in 13 different plays across the U.S. and Europe, and Germany and the UK. And we started out like most people did in the Barnett, but taking positions in Johnson County based on some of our work on thermal maturity before many of the horizontal wells were ever drilled. We then did a project for Marathon Oil where we were asked to look at the Appalachian Basin and worked up and put together the Marcellus play. And this was back in 2008 when there was only 3 horizontal wells drilled in the play. The plays I'm going to show you are primarily oil plays, And then in about 2009, we started focusing our attention on oil resource plays. So what I'm going to show today are 4 of those plays. We're going to look at the Woodford Shale Mississippi Lime play that we put together in about 2009. Then we're going to move over to the New Albany Shale that we put together shortly after that for our clients, Kimmeridge Energy, and took about a 65,000 acre position there. We have about 60,000 acres in the Woodford Miss Lime. And then what you're going to see is the evolution of our thinking and starting to think about hybrid plays, not just source rock plays, but the coupling of reservoir and source rock. We'll do that by showing an example over in the Paradox Basin, and then we'll move over to the Animas Arch, a pure carbonate resource play, where I want to emphasize the importance of the relationship between the petroleum system and the storage system. Okay, so as I go through these 4 plays, you're going to see several consistent themes. Probably first and foremost is the importance of the petroleum system and a set of screening criteria to guide us. Where did the oil come from? How did it get there? And where is it? The other key thing you'll see throughout this talk is the idea of technological advances. In other words, we're going into old basins and old areas and looking at those old wells and these underdeveloped areas and asking ourselves, what can we do today to make something old new again? And I can't say enough about creativity and our team. It's great to have highly competent geologists and engineers, but at the end of the day, for new play generation, we need people that sit around every day and say, how come? Why not? What if? And you're going to see that theme over and over again. And of course, I love my dad's famous quote drilled into me at a very young age, and that is, geology is a science, and exploration is a business. So we'll look at some of the, starting with the business idea before we get into the technical. We'll talk about economic screening criteria. Now this holds true, I don't care if it's $30 oil or $100 oil. For us, the driver to successful projects is early entry. And early entry in the best part of the plays. That equates generally to lower entry cost and higher performance. And you'll see that as a recurring theme. Understanding of corporate metrics. Well, you know, we're a small family-owned company. We have no debt, and we work within cash flow. We've been able to grow the company organically because we focus on payout. How soon can I get my money back and invest it in the next well? So I like all the corporate metrics, but honest to goodness, we spend a lot of time with the back of an envelope. Marketability of the play. This is an important consideration every time we're looking at economics, looking at plays, because we're not in the development side of the business. We need partners, we need to be able to de-risk these and ultimately sell them. So we look at marketability and execution risk. As an example, we had a great play in Alaska. There's some phenomenal source rocks in Alaska. But the problem with Alaska, as opposed to going to Oklahoma, is there's a limited market for people we could partner with, especially with it having to go through Prudhoe Bay, and the big companies control that market. So maybe the best play in the world, but darn it, I'm not going to be able to execute on it. And as many of you guys that work the Western U.S. know, the BLM ain't what it used to be. I mean, 10 years ago, I could go in and quietly nominate 100,000 acres in Nevada and go to a lease sale and bid on that within 6 months. It's just not even an option anymore. It takes 2 years. By then, that's not early entry. If I've got to wait on the BLM to put the stuff up for the sale. New York, hey, the Marcellus is in New York, but I can't touch it. So we think about that, and we think a lot today especially on acreage size. You know, it used to be where a lot of people said, oh, we need 100,000 acres, but I don't really want 100,000 acres at the get-go. We're thinking a lot about where can I go in and get 10,000 acres, 5,000 acres. can I quietly de-risk my play and stay under the radar and see the upside around me and know that in a success case, hell, I'm happy to spend $1,000 an acre or farm in or buy production in a success case. So acreage size has changed a lot recently in our thinking. So geologic screening criteria, I'm giving you guys the very basic. I think of geologic screening criteria as a spatial Venn diagram. It's the overlapping map, first and foremost, of the petroleum system, of the source rock. That's the heartbeat of every play. So we make our maps of thermal maturity, mineralogy, thickness, organic quality. We all do this. But it's the usage of software programs such as ArcGIS, Petra, where we can overlay those maps and look for the best area of the source rock. Well, now more than ever, especially in low price environments, we're very interested in understanding the criteria for storage and delivery. It's not enough just to have a great source rock. We got to get it out, and we've got to get it out at a good rate. So you'll see this. Obviously, each play has got a multitude more criteria, but this is always the fundamental. So we'll dive into some of these plays now and illustrate some of the thinking. We're going to talk about 4 plays. I've just got a couple slides on each play to illustrate, first and foremost, the thinking. What set off the light bulb for us to put our own money in leases before any horizontal wells were drilled, before we had quantitative core analysis in many cases. So we'll look at the Woodford Shale Mississippi Line play we did in 2008, and we're going to look at some of the early hand-drawn maps and some of the indirect evidence we had that built an extension of the existing play in a brand new area. We'll then go over to the Woodford equivalent in the New Albany Shale and look at more quantitative analysis we did with rock eval pyrolysis to high grade the area, hone in on the sweet spot, as well as vertically within the New Albany, the best areas of that. Then we're going to jump over to the Paradox Basin, where you'll see the evolution in our thinking to storage and delivery, where we've looked at coupled systems of source rock, reservoir, and seal. And then as to go to the end member, we'll look at a pure carbonate play, a tight carbonate play in the Mississippi and on the large Los Animas Arch, where we had to understand the migration and petroleum system and its importance in understanding the reservoir type that would hold the oil. And we'll do that by looking at some core work and capillary pressure work. So let's start with the Woodford. Now, this slide is an old slide back in 2008, and when we were sitting around thinking one day, we were looking at the Woodford, what a great source rock. I mean, at the end of the day, start with the good stuff. And we knew the Woodford had generated over 30 billion barrels of oil in the mid-continent. Sounded like a pretty good place to start. But at the time, the Woodford play in 08 was confined pretty much to the Canna play, the deep gas play. Remember, this is when gas prices were 12, 14 bucks an M. The Arkoma Woodford had taken off, but there were some oil tests in the highly structurally complex Ardmore Basin. But we knew that there was more to the Woodford play than what was shown on the continental maps. The old maps indicated that at about this line here, the Woodford went to 25 feet and that it was just barely in the oil window. In fact, up on the shelf, the old map showed thin Woodford and immature Woodford. But we knew better. We knew better. We knew that, and again, these are hand-drawn maps that we've scanned. This is how we did it, still do it to some extent. The clue to knowing that we had a play in the Woodford up on the shallow shelf was actually in the Mississippi line. So this map is a drill depth map on the Mississippi line. We're focused here in Kingfisher County, Logan County. This would be the Nemaha Ridge right here. This is the deep Canna play. And one of the things that was the clue was that when we looked at the Mississippi line in this area, it's a fractured, tight oil play, and there's oil production for both the fractures and the very low perm matrix. Well, you can't do that by migrating all the way into that from the basin. This stuff has no lateral permeability. The other thing we knew is it had very low water cut. So it was our belief that the Woodford had to be below us and generating in order to impregnate those very small pore throats. So we began to look at just fundamental data. Now, the first clue was that when you looked at the hydrocarbon occurrence in the Mississippi line, it's almost entirely oil up depth shallower than 9,000 feet. And at about 9,000 feet, it turns to gas. We thought, this may be a maturity proxy. But what we had to do was find direct evidence of oil in the Woodford. And we did this by looking at hundreds and hundreds and hundreds of completion tickets, strip logs, mud logs. You don't find plays in IHS. Forgive any of the IHS or drilling info reps, but honest to goodness, it's forensic. We had to go and prove that there was actually oil in this rock. Well, how do we do that? We spend a lot of time looking at mud logs and going to the survey and getting old cuttings and looking at every completion ticket. So we were lucky in this area. We had really only 2 modern mud logs with a chromatograph. And what we could see in the Woodford when we first looked at it was oil, clear oil on mud log. And what we also saw was that the Woodford was over 100 feet thick here. The high gamma ray gave us confidence of organic quality, but what was unusual was the thickness here. And we did all of our mapping and our stratigraphic model. What we could see is that there was a localized strike valley that was parallel to the Hunton subcrop. So we were able to map that out. So we had thick organic Woodford, we had oil shows, and we had good high resistivity. And you can compare that to the inorganic Sylvan shale. So we like looking at the resistivity as another confirmation of oil. But how do we really know if there's oil in the rock? We run our own mudlog oil show work in our office. And we have 2 ways of doing that. And I'm going to show you an example. This is a strip log. For those of y'all that know my dad, we went and gathered boxes and boxes of cuttings, and he sat there in his garage running these samples and describing them by hand and running oil show analysis. We have 2 ways we do this. This is old school stuff, and I don't know if y'all have ever tried this. The first way is the dilute hydrochloric acid test. Anybody familiar with that? There, I see somebody nodding. Take 15% hydrochloric acid. Just go to your local pool store, get muriatic acid, and you take a little cutting and you drop it in there. And as the CO2 bubbles begin to emerge, the oil comes out as a surfactant. And it coats those bubbles, and it causes the bubbles to float. They break, they fall. The surfactant attaches, they float up like a little parachute. And they bob like champagne bubbles. Now, that is an old school thing. Try it sometime. Try it. And so the other thing we started finding out is that as we got into the shales that are very, very tight, we had to do crushed analysis. So I want to shout out one of my geologists here, Liz Block, who actually came up with this creative way to, as she says, make the rocks talk. So we take these cuttings and we purchase a solvent that it's not illegal, that's the wrong word. We can order it. We can order it from the scientific labs. We just have to be careful with it. And I always say we'll find out in about 20 years if it's a problem. But no, really, it's just paint thinner, really. And so what we do is we take these cuttings and we crush them to a fine powder. We put them in a little vial of toluene. Now, because these are such low permeability, I mean, there's no sign of oil when you first look at them. So we put them in there and we shake it and agitate it so that we're actually dissolving the oil in the toluene. And then we take a photo. This one would be no show. And then this is a photo, white light and UV. And that toluene, the oil will dissolve in the toluene. Now we had a lot of questions. Are we, especially since we're doing this in carbonate-rich rocks, are we seeing calcite? Are we seeing mineral fluorescence? So Liz had the brilliant idea. You were just doing this over our drafting table. No vet, but that's another story. Don't tell my landlord. And so then what we do is we took a coffee filter, and so we decanted after the stuff had settled. We decanted, put it through a coffee filter, and then we put it in a dimple tray. We let that dry. And I tell you, this is oil. That is an oil show in a tight rock. That if you just put that rock under a fluoroscope, you wouldn't see anything. It takes this to be able to make the rocks talk. Now, it's not quantitative, but it tells me, darn, I got oil in this rock. There is oil in this rock. So anyhow, that's our little show analysis. So on the Woodford, what we were able to do is take the combination, this is again just an old hand-drawn map, of where we had Mississippi, in green, where we had Mississippi lime production in the Sooner Trend as a proxy. Then we took our isopac map and we overlaid where we had Meisner sand. Now Meisner is a lag sand at the base of the Woodford, and in our area where it's thick on this Stripe Valley, it's actually reworked at the base of the Woodford. And we took all that, and with just this data that you've seen, we high-graded an area of 4 townships and started taking leases before we had any quantitative work, before there was any production. We bought those leases at $50 an acre. Now, we went in today, I'll just jump where there's obviously been a tremendous amount of work between this and today. We partnered with one of our industry partners, Longfellow Energy. They're in Dallas now, acquiring and growing the position to 60,000 acres. We now have 80 wells, 80 horizontal wells producing in the trend, both from the Mississippi Lime, the Woodford, as well as some of the shallower horizons. And so anyhow, this was all done early on with just some basic fundamental mapping and show analysis. So next we're going to move all the way over to the Illinois Basin. And what drove us to the Illinois Basin is we knew that New Albany was a Woodford equivalent. And as we usually do in our shop, we're sitting around with our feet up, looking at maps of production in the U.S. and just thinking, just going, I wonder where the next really great source rock is. And it was weird. When we were looking at the New Albany, and this is a map, this is the boundary of Illinois and Indiana, the old EIA maps and all the old shale maps, when they talked about the New Albany, it was a biogenic play, right? The New Albany's biogenic. And they always showed the New Albany play as being this biogenic gas play up shallow in Indiana. And we're sitting there looking at these production maps of the Illinois Basin. Look, my God, there's 5 billion barrels of oil in the Illinois Basin. There's got to be a major source rock. The New Albany must be thermogenic in the center of the basin. And I think the reason why nobody was in there early on is that when you look at a map of the Illinois Basin, there's 200,000 wells. How are you going to make a play there? But it's stripping it down to its simplicity. When we took off all the wells except for the penetrations to the New Albany, only 10% of the wells in this whole area ever penetrated the New Albany. And when you go to the deepest part of the basin, only 1%. And we knew that we wanted to be in the deepest part of the basin. Why? We wanted the pressure, and 2, there's no gas production, so we knew it was going to be marginal, and we wanted to be in the deepest part of the basin. So armed with that, we began making all of the appropriate maps, but probably the most important piece of evidence for us was some of the quantitative work we did with rocky valve pyrolysis. So this is a drill depth map on the top of the New Albany Shale with the deepest part of the basin in the center. This is three counties, or about 1.5 million acres. And there was a tremendous amount of Tmax rocky valve pyrolysis data available through the USGS. We have a very simple approach to looking for our oil window. We just merely take all of that data and we plot it on a regression with maturity versus drill depth. And we merely take the data and say approximately what depth do we in general enter the oil window, and at what depth do we enter what we'll call the better part, or Tmax about 440, 450. And then we could put that on a map and look at the area involved. So the black area was where we had Tmaxes of 440 or greater. That's good, and in some cases up to 460. We can color code the control on thermal maturity to just kind of check our assumptions. So blue are all the values that are immature, and then the whites and greens are the highest maturity. So this led us to believe then that we could focus our work just in these 3 counties here and be in the deepest part of the basin. Now what we loved about it is that when we first started pulling our mud logs and our logs as we do, the similarity to the Woodford is striking. You have the same high gamma ray. It's separated into 3 units, the Grassy Creek, the Sweetland Creek, and the Bloker Shale. But we have that same high resistivity, but what's different than the Woodford is that the New Albany has a higher carbonate content, and we could see that. We thought it might even be more fracturable. But what was unique on all the mud logs is we just had gas shows. Well, this is not in the gas window. So this was a measure of the permeability. The New Albany is very, very low perm. So it became extremely important at looking at which of the units within the New Albany have the best storage and the best permeability. And we have a little tool we use, a little derivative called S1. Is anybody here familiar with rocky valve pyrolysis and the S1? So great. So what happens when we do pyrolysis? The very first thing that comes up as we start heating the sample is that we actually start volatilizing the oil. We actually extract the oil when the sample is first heated. Most of us think of Tmax, which is the S2 peak, but we care about the S1 peak. Why? That is a direct measurement of oil in place. In fact, it is a low number. So that volume measured in milligrams per gram is a measurement of oil in place in that particular rock sample. We did a paper with some engineer colleagues of ours and published it in AAPG and presented it at AAPG, where we can take and use the S1 data from pyrolysis and gross that up to barrels per acre or millions of barrels per section. And so we have a rule of thumb of about S1 of 1 equals about 1.6 million barrels of oil in place per section per 100 feet. And that is a low number. But what I really like about using it is that when you have enough data through either spatially, you can look at spatial variations, but vertically, this is an example from that last New Albany well you saw. We can look at the S1 in the various members. And when we see S1s as high as 7, and everything's in the same maturity level, that gives us some indication on storage. It's not just Tmax. I mean, it's not just TOC. That TOC's been converted. So the higher the S1 within an interval is usually the better reservoir. And so we've used this as a guide to land our first horizontal in the Grassy Creek member. Well, as you can tell, I'm trying to just hit the highlights of each of these plays to show you some of the ahas that really made us feel like we had a tiger by the tail, like we say. So as we were sitting around, and as we do with our feet up on the desk thinking about what's next, we started looking at this issue of storage and where we can find the best delivery mechanism. We started thinking about this concept we called coupled systems. We thought, well, these source rocks are great, they're fantastic, but where can we go where we have a reservoir in direct communication with a source rock so that we can get that delivery mechanism? And we went to the Paradox Basin for a couple simple reasons. One, our company has a massive database of geochemistry that we've accumulated through the years. And when we looked at these Pennsylvania shales of the Paradox Basin, these things are enormously rich. High TOC, high S1, and they were in the oil window. The issue with the Pennsylvania shales, and they occur throughout the entire mid-continent, is that in the Paradox Basin, they're relatively thin. We don't get 300 feet, we get about 50 or 70. But as we started looking at some of the mud logs, and we were mapping those out, we saw a unique pattern. So the key to this play was one that we call a coupled system. When you look at the interval, and we're located here in right at the Utah-Colorado border for all of you that know Aneth Field. All the fields here produce out of these Pennsylvania carbonates. But what we notice that these carbonates laid on either side of the famous Gothic source rock. Here it gets to be about 70 feet thick. And what we could see is not only did we have a source rock and that we had reservoir on either side that was oil charged, but we had these anhydrite layers that formed a seal. So we knew we had the source rock, we knew we had the storage and delivery mechanism, but what the seal gave to us was deliverability, because these seals set up a pressured cells, pressured systems. And we know that by looking at the core. So we took a couple core through this section, and these are expulsion fractures. You see these and the reason I know that is because there's crystallization, mineralization on the faces. We see this in the Bakken. And this gives us an indication of the tremendous amount of pressure that is generated when these shales start converting their carriage into hydrocarbon and shove it into every small pore space they can find, and then capped by these anhydrites. So the screening or the high grading criteria for us on this play then was to really look at total thickness of the interval, with really the source rock being the main criteria. So we made our isopac maps of the source rock, and then with the thermal maturity data we had, we wanted to be in the condensate window or just into the oil window. So we focused our exploration, our leasing in this area and here, where we had both good thickness, good pressure, and gas or oil or condensate. And we stayed away from the deep play that Bill Barrett made in the thick Gothic, which is primarily gas. And over in the east area, there's salt. Salt starts encroaching into the section, and that was a terrible disappointment for them, because as they tried to frack the Gothic in that area, they had salt precipitation in their tubulars, and their wells just died. So we managed to back away from the salt basin and be in the oil window. So we hold with our partners, Kimmeridge Energy, over 50,000 acres in that play, and we're permitting the first horizontal in this area here soon, hopefully. Okay, so next, we've looked at pure source rock plays and some of the thinking. We've looked at sort of hybrid plays and some of the thinking. Now I'm going to go to the end member of a pure carbonate play. And this is on the Los Animas Arch in southeast Colorado. For any of y'all that know the area, we're bounded by the Denver Basin on the west and the Anadarko Basin to the southeast. And this is a gigantic structural feature. And what I want to convey on this play is the importance of understanding that hydrocarbon generating system and how it is important to understand your reservoir and which rock can actually hold those hydrocarbons. Well, what brought us to this area first, so we had been working the Mississippi Lime, is we made a map. We were exploring in the area. We made a map of structure on the top of the Mississippian, and we saw all this Mississippian production. Y'all are familiar with this. It's Anadarko Basin, Mississippi Lime. And what we knew is that the Woodford source rock pinches out about here. There is no Woodford up on the arch. There's a steady pattern in pore throat size of the Mississippi Lime. So what happens is we're to the south, and the play I showed you earlier is that because the Woodford is just below us, we can have oil in very tight rock because we've got the pressures to impregnate those fine pore spaces. But as you move out of the Anadarko and you come up into Kansas, what's the problem with the Kansas play? Well, it's because it's almost conventional. It's very large pore throats, very high water cut. Why is that? It's fundamentally a buoyancy issue. That as oil travels long distances, the pressure drops, and it can only enter pore spaces that are large. But what we notice on the Los Animas Arch is that oil couldn't have been Woodford, because on the arch there was oil in porosities as low as 4%, low perm reservoir. So we knew that there had to be a local petroleum system on the arch to charge this Mississippian carbonate. So as I mentioned, this is some of the fundamental thinking that I benefit from, my dad and old school. This isn't even really old school. This is just basic fundamentals. And he presented this paper in a number of places called Thinking Like Oil. And the importance of us to really think how a droplet of oil thinks. And the droplets of oil function on very simple physics, and that is buoyancy. So the basic idea is under low pressure or long migration distances, that oil can only enter the largest pore throats, and it will never be able to displace all the water. So if you're looking for tight oil places, you've got to be near a generating system, because you need that very high impregnation pressure, a very high column, in order to force oil into these small pore throats and drive out all the water. So this is fundamental thinking, fundamental physics. So what we did on the arch to convince ourselves that we had a ubiquitous large-scale play is we make maps. This is the arch here, large structural closure. Each of these are a county, so this over 3 million acres. And we make maps of very simple maps we call production, test, and shows. We want to look at all hydrocarbon occurrences and look at every single occurrence of oil, either through drill stem tests, production tests, mudlog shows, our own core analysis. And then we want to look at what rock the oil is in. So we focused our leasing up here where we had just ubiquitous oil indications. Now, On the main part of the arch, where all the historical fields are, there, the Spurgeon dolomite, which is the main play, is very well developed because it's on a paleo high. So you have very high porosity, and all of the historic production on the arch is in rocks that is 10% and more porosity. On the arch, any time anybody looked at a porosity log and it was less than 10%, they did not complete those wells. So we knew that the prize on the arch is all this oil off the main structural trend, stratigraphically trapped in this discontinuous, low perm, low porosity rock that had never been developed. So we had to get quantitative on this to really understand which rock would be oil saturated. So this is an example of where we actually went out and actually took a core. We did a bottom hole contribution and took a core through the Spurgeon. So this is a neutron density log. You can see the Spurgeon dolomite and the separation in neutron density. And then this is 18 feet of core in this interval right here. So it's very clear when you put this stuff on UV light where the oil is in the dolomite. But what was really astounding is that when we did our core analysis, when we did our GRI work and looked at the poroperms, this is clearly oil, but you probably can't see the numbers, so I'll just tell you. I have porosity and water saturation. This is 3% porosity, that's 7% porosity, that's 8% porosity, that's 4% porosity. So oil was able to get in these very, very fine pore throats because we have a generating system, and it's the Pennsylvanian carbonates that we all, as Pennsylvanian source rocks, same ones as we see in Paradox Basin, are present here and are getting into the Spurgeon dolomite via fault juxtaposition. So some of the other work we do, so anyhow, so we can see the oil, we have it in the core analysis, but we also took cap pressure work because we wanted to see the fine scale variability in the reservoir. So this is an example of the cap pressure work we did. Now what's important is that all these cap pressure points, that core was right in here, all those cap pressure points are within a 10-foot interval. But what is astounding, and this is why I love carbonate resource plays, is I want variability. I want to see heterogeneity. So when I go horizontal, I have just as good a chance of picking up 10% porosity as I do 4. I don't care. I just want to know where the oil is. So if you look at the cap pressure data, the way you read these curves is going to the left is higher oil saturation, and going vertically is estimated column height as a function, as converted from the capillary entry pressure. So they basically are shoving mercury into this rock and seeing which rock will take it and which won't. And so the red curve is seal rock, and that point is right here. That's seal. You'll never get oil in there in a million years. But as you move to the left, we start seeing oil saturation, and we could qualify the type of rock type that could take oil. The better the rock, the lower entry pressures, and we saturate that rock immediately. But what's astounding is you can see in a carbonate reservoir the extraordinary variability in 10 feet. And again, for resource plays and horizontal plays in carbonates, I want that. But I need to know which rock can have oil and which can't. And so we use this information then to be able to estimate what is the minimum cutoff on our reservoir quality so we can start making oil in place maps and get a sense of the size of the prize. Now, this is a graph I like to make. It shows porosity at the bottom. This is from all of our core analysis and cap pressure work. All the porosity going to the right, permeability going up, and then the bubble sizes are water saturation. And what you can see is at about 3 microdarcies, the oil can get in. The oil doesn't care about how many holes I have. The oil and the pressure cares about how I can get between those holes. So what you can see is there's a very clear permeability barrier cutoff to oil. And that occurs, this is 3 microdarcies. At 3 microdarcies, I start getting oil saturations. Now that's pretty tight rock, but I can't map permeability on my logs. You know, we're old school. We're actually using 1,000 raster logs and hand picking this because I'm too cheap to buy LAS logs for 1,000 logs. So we just have a great staff that can sit there and pick this stuff. So we use porosity then to do our resource analysis. And so the only thing I could really do is try to find a regression and a relationship between permeability and porosity, but it pretty much converged on what we saw in the core, and that is about at 4% porosity, we start getting oil. So on the arch, the idea is this is a tight carbonate play. We can understand which rocks have the oil. We can then calculate the size of the prize and then go after all of that undeveloped oil on the arch. And we have about 50,000 acres here on the arch. And this is a tough play, especially in this price environment. We can't frack this stuff. So we're looking at various completion and horizontal drilling techniques. If we frack it, we'll get into the water-bearing zones. So we're looking at a number of novel horizontal drilling techniques and completion techniques to get this out. So I went through these pretty fast, and just to give you guys a little taste of what we're doing in our shop to think and create new plays, and I hope it gives you guys some ideas or confirms some of the things you're already doing. I'm hoping that everybody sees that, you know, you just can't stick with the same playbook year after year. We have to take our lessons learned, our failures, our successes, and let our play concepts evolve over time related to commodity price technology, but learning's more than anything. Fundamentals of the petroleum system, where is the oil? How did it get there? How do we get it out? And that the identification of the core of these plays is absolutely critical, especially in the low price environment. And as I like to say, you know, I know these are tough times, but I think as an explorationist, it's actually a great time. It's a fantastic time to be an explorationist. We have time now. We're not chasing drilling schedules. There's not more dollars than cents chasing fringe. We can sit back and do fundamental exploration and get into the best parts of these plays. And with that, I'd just like to give some acknowledgments and recognition. For sure, my staff at Roxanna Oil Company, that their creativity and all the work they do has led to all our successes. My dad, Marlon Downey, he's been a mentor to me, chairman of our company. I'd like to thank our clients. We just finished a 5-year exclusive contract for them, a $250 million fund, and they invested in all our ideas. We co-invested with them, Los Animas, New Albany, Paradox. Then all our other partners that we've done deals with, I want to thank them for investing alongside us. We have a number of publications. If anybody's interested, you can go to our website and download many of these publications. And then AAPG asked that we would publish this on their Search and Discovery forum, and so it'll be available on Search and Discovery. So I know that was a lot of stuff. I really appreciate everybody's attention and appreciate y'all coming today. Thank you very much. Honestly, how do you say we interact? We're very informal. I mean, when I say we sit around with our feet up on the desk thinking, no joke. I mean, we get together weekly and talk about ideas. I don't know how to describe it. You know, we don't have meetings. We don't have diversity training. We just, I left the company 25 years, and I have never been happier to get to do what we follow our nose. That would be the best way to describe it. Somebody has an idea. Liz says, well, what about the paradox? And then Avery says, yeah, maybe they might have a carbonate member. Max, our geotech, says, I'll go find the data. We go, well, let's go check it out. Then I'll review, that looks good. I think, and then talk to Dad. Hey, kid, I think you got tiger by the tail. And no joke, this is how this stuff evolves. We're forensic scientists. We're detectives, and we have a lot of fun. Would you say that's true, guys?
Yep. I like the idea of puzzles and collecting pieces.
Yeah, it's a puzzle piece. We take all the puzzle pieces, we turn them upside down. We've got a few pieces that show themselves, and we say, is it a puppy and a planter, or is it a flower? And then we just start adding data to that, and then we make an interpretation. And then, anyhow, thank you, Charles. That's a good. I agree with you, and I think I'm not worried about having 100, I think someday it'll be back at 100, but what we're really focused on is how can we make it work now? And not to give away too much stuff, but we just drilled our first successful, operated and drilled our first successful horizontal well in an old carbonate field in the Forest City Basin. We made more on that one horizontal well than that field's produced, than that field produces in total. So you know, you just gotta keep thinking, you're right, what if, how come, why not? What else? Let's see, yes, sir.
It's good to be reminded to think of anthropomorphically about the oil sometimes. In not all of your cases did you start with find the source rock and then see where everything went.
Not always.
Sometimes empirically.
Absolutely.
This is here, and then figure out, try and back it out.
The Los Animas Arch is a classic example of that. We couldn't explain. In fact, there had been all this work by GMR trying to, and Anadarko trying to find a source rock for the Spurg and Dolomite. And we backed into it. We did some actually very novel work. We did some bottom hole temperature gradient work from the old well logs to map thermal anomalies on the arch. And there's a very strong thermal anomaly. And we noticed that these Pennsylvania shales, these cyclic Pennsylvania shales, had to be the source rock. Had to be. And then we could see the juxtaposition, and we could map the migration pathway, and it just came together. Couldn't be the Woodford. So no, we don't always. We just kind of look where the oil is and make sure we understand the system. Had another question in the back. Yes,
Yeah,
sir.
what percentage would you say of your ideas when you sit around with your feet up on the table does your come to dead ends?
Oh, 80%. 80%. But what we do different, and again, I spent 25 years at Marathon Oil. I was an exploration manager there. It's a great company. It's a great teams there. But what we're able to do that you can't do at a big company is we just look at data all day. I'm not looking at anything else all day, other than, yes, I got to run the business, but we're looking at data all day long, morning to evening, and thinking. We're not distracted by anything else but looking at data, and just hundreds. You go into an area like the New Albany, the Illinois Basin. Liz, how many wells did you look at? You looked at every single completion ticket, like 500?
In the 3 counties, the one that go to New Albany and deeper was 300.
300. She did this as her summer intern project, so I hired her. plus, I might add, she's a Longhorn. So I always say that people ask, Julie, why are you and so many people in your company from UT and are women? I say, oh, I just hired the best and the brightest, that's all. Sorry, guys. High five. Anyhow, I'm sure more questions. Yes?
Yeah, I love the idea of the pathology. I'm just wondering if, in your course of investigations, have you found use for geophysical applications in what you're doing?
Thank you for asking that. I didn't mean to imply that we don't. It's just that we're so far on the early end of things. I mean, we're going in there before the horizontal wells are being drilled, and there's just no 3D. There's just none. The Los Animas Arch was unique in that about the time we were getting into it, Chesapeake just blew us away and just covered that area. And they actually caused the second largest onshore 3D to be shot there. And I have looked at that, and there will certainly be some applications for that. But in the early stages, it's just not available. We do 3D with well logs, basically. Yeah, good question. Yes?
At which point do you decide to go from that forensic kind of approach and looking at the data that you have to taking that next step and flipping over a different puzzle piece? When do you make that decision?
Yeah, I would say it has to do with the root risk, if I will. So we go and try to make sure we have the fundamental elements for sure. And then we're saying, okay, so what is the critical risk of the play? If the critical risk is, say, I just have to know whether I'm in the gas window or the oil, I need that thermal maturity data, we'll go do that work. Or, in the case of Los Animas Arch, we needed capillary pressure data, and we needed it from fresh core. It was just a fundamental risk. We didn't understand the pore throat geometry. We didn't understand which rock. We needed to be able to determine what is our cutoff, and not just from guessing. And honestly, and again, not to offend any petrophysicists, but not from petrophysical evaluation, but from actual core analysis. We had to have that. So we, spent a good chunk of change with our partners to actually take that core. So it's really, what is the controlling risk on the play? Yeah, good question. Well, anything else? Thank you, guys. That was fun.